Hello everyone. So today in this we will discuss about the chapter number 10, that is gravitation. In the earlier chapters we have learned that about the motion of the objects and force as the cause of the motion. Also force is needed to change the speed or direction of the motion of an object. In this chapter we shall learn about gravitation and universal law of gravitation. We shall also discuss motion of objects under influence of gravitational force on earth. We shall also study how weight of the body varies from the place to place. So now gravitation. We know that moon goes around the earth. An object when thrown upwards reaches a certain height and then falls downwards. It is said that Newton was sitting under a tree, an apple fell on him. Newton started thinking. He thought that if earth can attract an apple, can it not attract the moon? He concluded that in the both cases same type of force is responsible. Now we shall take a small activity. Take a piece of thread, tie a small stone at one end, hold the other end and whirl it round. Observe the motion of the stone and release the thread. Again observe the direction of the motion of the stone. Before the thread is released, stone moves in a circular path while certain speed and charges direction at every point. Change in direction involves change in velocity or acceleration. Force that causes this acceleration and keeps body moving along the circular path is acting towards center. So this force is called centripetal force. Thus, straight line will be parallel to the circular path. For example, motion of moon around earth is due to centripetal force. It is provided by force of attraction of earth. In our solar system, all planets go around sun. So we can say that there exists a force between sun and planets. So this force of attraction between the object is called as gravitational force. So now the next topic is universal law of gravitation. Every object in universe attracts every other object with force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. It can be written as F is equal to gmm upon d square. Derivation of this can be written as let two objects A and B of masses capital M and small m lie at a distance d from each other. Let the force of attraction be equal to F. According to the law, F is proportional to the capital M into small m. Also, F is proportional to 1 by d square. That is, F is proportional to capital M into small m upon d square. That is, we can write it as F is equal to G into capital M into small m upon d square, where G is constant of proportionality. It is also called as universal gravitational constant. That is, we can also write it as G is equal to Fd square by m into m. SI unit of gravitational constant is Newton meter square per kilogram square. So now we will take a small example. Let mass of earth is equal to 6 into 10 raised to power 24 kg and that of moon is 7.4 into 10 raised to power 22 kg. If the distance between earth and moon is 3.84 into 10 raised to power 5 km, calculate the force exerted by earth on moon. Let gravitational constant be equal to 6.7 into 10 raised to power minus 11 Newton meter square per kilogram square. So now here mass of earth, that is capital M, will be equal to 6 into 10 raised to power 24 kilograms. Mass of moon, that is small m, will be equal to 7.4 into 10 raised to power 22 kilogram. We have to calculate force exerted by earth on moon. Here the distance d is 3.84 into 10 raised to power 25 kilometer. That is 3.84 into 10 raised to power 8 meter. Also, gravitational constant G is equal to 6.7 into 10 raised to power 11 Newton meter square per kilogram square. So now putting this in equation, that is F is equal to G into capital M into small m upon d square, we will get, by substituting the value, the answer, that is force exerted by earth on moon, will be equal to 2 into 2.02 into 10 raised to power 20 newtons. So this was the basic example of universal law of gravitation and its application, that is constant of proportionality also called as universal gravitational constant. So now we will look what is importance of universal law of gravitation. First is force, it is the force that binds us to the earth. Second, the motion of moon around the earth can be studied by universal law of gravitation. Motion of other planets around the sun is also studied by this gravitation universal law of gravitation. Also, the tides due to moon and sun is also studied by the universal law of gravitation. So this universal law of gravitation is very much important. So now the next topic is free fall. We all have learned that earth attracts objects towards it. So whenever objects fall towards earth under this force alone, we say that objects are in free fall. While falling, there is no change in direction of motion of objects, but due to the earth's attraction, there will be change in magnitude of velocity. Whenever an object falls towards the earth, an acceleration is involved. Acceleration is due to the earth's gravitational force. Thus, this acceleration is called as acceleration due to gravitational force of earth. It is denoted by small g. So now, taking off the derivation, we will take it as let m is equal to small m is equal to mass of object, g is equal to gravitational force. So we will write F is equal to mg. So now mg will be equal to g into capital M into small m upon d square. We will write it as g is equal to capital G into capital M upon d square, where capital M is mass of earth, small d is distance of object and earth. Let radius of r be denoted by capital R. So we will rearrange the equation as mg is equal to g into capital M into small m into upon r square. We will write it as small g equal to g capital G into m upon r square. So now we will derive value of small g, that is gravitational force. Now here capital G will be, that is universal gravitational constant, will be equal to 6.7 into 10 raised to the power minus 11 Newton meter square per kilogram square, and capital M will be equal to 6 into 10 raised to the power 24 kilogram, that is mass of earth. Also radius of r capital R will be denoted by capital R, which can be written as 6.4 into 10 raised to the power 6 meter. So small g is equal to capital G into m upon r square. By substituting the values of the respective terms, we will get small g as 9.8 meter per second square. So the value of acceleration due to gravity, that is small g, will be 9.8 per meter per second square. So this is how we calculate the value of the small g, that is value of acceleration due to gravity. So now we will study motion of objects under influence of gravitational force of earth. So now as small g is constant near the earth, all equations for uniformly accelerated motion of objects become valid with acceleration a replaced by small g. That is, equations will be v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. In application of these equations, we will take acceleration a to be positive when it is in direction of the velocity, that is direction of motion. Acceleration a will be negative when it opposes the motion. So now we will take a small example. Car falls off a ledge and drops ground in 0.5 seconds. Let small g equal to 10 meter per second square. So we have to find first what is its speed on striking ground. Second, what is its average speed during 5 seconds. Third, how high is the ledge from the ground. So we have been given that time t equal to half second, initial velocity u equal to 0, small g is equal to 10 meter per second square. Acceleration of car small a will be equal to 10 meter per second square. It will be positive as the motion is in downward direction. So now first speed will be equal to v is equal to u plus at, but here initial velocity u is equal to 0, so v is equal to at, that is v equal to 10 into 0.5, that is final velocity v will be equal to 5 meter per second. So now second, average speed, it can be calculated by u plus v upon 2, that is 0 plus 5 upon 2, so it will give average speed equal to 2.5 meter per second. The third one is we have to find distance travelled, s is equal to ut plus half at square. but as initial velocity u will be equal to 0, that is we will neglect that ut term. So we will be remaining with s is equal to half at square, that is half into 5 into 0.5 whole square, that is half into 10 into 0.5 whole square. We will get distance travelled will be equal to 1.25 meter. So now we will take another example. Object is thrown vertically upwards and rises to the height of 10 meter. Calculate first velocity with which it was thrown upwards. Second, time taken by object to reach the highest point. So now here distance travelled is equal to 10 meter. Final velocity v is equal to 0. Acceleration due to gravity small g will be equal to 9.8 meter per second square. Acceleration of object A will be equal to minus 9.8 meter per second square, as it is in upward direction, which is opposite to the that of motion of gravity. So first we will find velocity, that is equal to, we will use formula v square is equal to u square plus 2as, that is 0 is equal to u square plus 2 into 9 minus 9.8 meter per second square into 10, that is we will get minus u square equal to minus 196. So we can write it as u is equal to 14 meter per second square, also 14 meter per second. So next one is we will be required to find time taken. So we will write equation v is equal to u plus 80. Here v is equal to 0, u is equal to 14 meter per second, a is equal to minus 9.8. So we will get value of t equal to 1.43 seconds. So now the next topic is mass. We have learned that greater the mass, greater is the inertia. It remains same whether the object is on earth or moon or even in the outer space. Thus mass on an object is constant and does not change from place to place. So now the next topic is weight. Weight of an object is a force with which it is attracted towards earth. We know F is equal to ma, that is F is equal to mg. Force of attraction of earth on an object is weight of object, that is we can write it as W is equal to capital W will be equal to mg. SI unit is same as that of force, that is Newton N. Weight is force acting up vertically downwards. It has both magnitude as well as direction. At a given place, weight of an object is directly proportional to mass, say small m, that is the capital W is proportional to small m. It is due to the reason that at given place we can use weight of an object as measure of its mass. Mass of an object remains same everywhere, that is on earth and on other planets, whether its weight depends on its location, because small g depends on the location of the object. So now weight of an object on the moon. Weight of an object on moon is force with which moon attracts that object. Mass of the moon is less than that of earth. Due to this, moon exerts a lesser force of attraction. So now we can calculate weight of moon as weight of object on moon as weight of object on moon will be equal to 1/6 its weight on the earth. So now we will take small example. Mass of an object is 10 kilogram. What is its weight on earth? So mass m is equal to 10 kilograms. Acceleration due to gravity will be 9.8 meter per second square. So weight will be equal to mg, that is 10 into 9.8, that is 98 Newton. So weight of an object is 98 Newton. Another example is object weighs 10 Newton when measured on a surface of earth. What could be its weight when measured on surface of moon? We know that weight of object on moon is 1/6 its weight on earth. That is weight of moon will be equal to weight of earth divided by 6, that is 10/6 Newton, that we will get answer as 1.67 Newtons. So weight of object on the surface of moon will be equal to 1.67 Newton. So now our next topic is thrust and pressure. Have you wondered why camel can run in desert easily? Why an army tank weighing more than 1000 ton rests upon a continuous chain? Why truck or motor cars have a considerable amount of tires? So this considerable amount of tire, that is wider tires. This phenomenon can be explained by concepts of net force in particular direction, thrust, and force per unit area, that is pressure acting on the object. We also know that Weight is force acting vertically downwards. So the force acting perpendicular to surface is called as thrust. When you stand on the loose sand, force, that is weight of your body, is equal to the area of your feet. When you lie down, the same force acts on the area equal to the contact area of your body, which is larger than your feet. Thus, effect of forces of same magnitude on different areas are different. In the above cases, thrust is same, but the effects are different. Thus, effect of thrust depend upon area on which it acts. Effect of thrust on sand is larger while standing than while lying. Thrust on unit area is called as pressure. Thus, pressure can be written as thrust upon area. So now, SI unit of pressure as is written as Newton per meter square. In the honor of scientist Blaise Pascal, SI unit is Pascal, that is capital P and small a, PA. So now we will take a small example. Block of wood is kept on a tabletop. Mass of wooden block is 5 kg and its dimensions are 14 to 10 cm. Find the pressure exerted by wooden block on the tabletop if it is made to lie on the tabletop with its side dimension as 20 into 10 cm. So now mass of wooden block is equal to 5 kg. Dimensions are 40 cm to 20 cm to 10 cm. Thrust, that is F, will be written as mg, that is equal to 5 into 9.8. So thrust will be equal to 49 Newton. Area of side will be equal to length into breadth, that is 20 into 10, which can be written as 200 centimeter square, which can further be written as 0.02 meter square. So now pressure will be equal to thrust upon area, that is we can write it as 49 upon 0.02, which will come out as 2450 Newton per meter square. Thus, same force acting on smaller area exerts larger pressure and smaller pressure on a larger area. This is reason why nail has pointed tip, knives have sharp edges, and buildings have wide foundations. So now we will discuss about pressure in fluids. Fluids have weight and exert pressure on base and walls of container in which they are enclosed. Pressure exerted in any exerted is confined by mass of fluid, is transmitted undimensioned in all directions. So now we will discuss the principle of buoyancy. When an object is immersed, the upward force exerted by water on object is greater than its weight. Thus, it rises up when released. For example, bottle. To keep bottle completely immersed, upward force on bottle due to water must be balanced. This can be achieved by externally applied force acting downwards. This force must be at least equal to difference between upward force and weight of bottle. Upward force is called as buoyant force. All objects experience force of buoyancy when immersed in fluid. Magnitude of buoyancy depends on density of fluids. So now we will discuss why objects float or sink when placed on surface of water. Take a beaker filled with water. Take an iron nail and place it on surface of water. Nail sinks. Force due to gravitational attraction of earth on iron nail pulls it downwards. There is an upthrust of water on nail, but downward force acting on nail is greater than that of upthrust. Now take as example of cork and iron nail of same mass. Place them on surface water. Cork floats while nail sinks. This happens because of difference in their densities. Density of a substance is defined as mass per volume. Density of cork is less than density of water. Thus, upthrust of water on cork is greater than weight of cork, so it floats. Density of nail is greater than density of water. Upthrust of water on iron nail is less than weight of nail, so it sinks. Thus, objects of less density than that of liquid float on liquid. Objects of greater than that of liquid sink in liquid. So now we will discuss Archimedes Principle. It states that when a body is fully or partially in a fluid, it experiences an upward force that is equal to weight of fluid displaced by it. Archimedes Principle has many applications. It is used in designing ships and submarines. Lactometers which are used to determine purity of sample of milk, and hydrometers used for determining density of liquids. So now the next topic is relative density. It is the ratio of density of substance to that of water. As relative density is the ratio of similar quantities, it has no units. So now we will take a small example. Relative density of silver is 10.8. Density of water is 10 raised to power 3 kilogram per meter square. What is density of silver in SI unit? So now relative density of silver is 10.8. So relative density can be written as density of silver upon density of water. So we can write density of silver as relative density of silver into density of water, which will eventually give us answer as the density of silver will be equal to 10.8 into 10 raised to power 3 kilogram per meter cube. So I hope you have learned this chapter. So now we will briefly learn what we have covered up till now. So the law of gravitation states that the force of attraction between any two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. The law applies to objects anywhere in the universe. Such a law is said to be universe. Gravitation is a weak force unless the large masses are involved in it. The force of gravity decreases with the altitude. It also varies on the surface of Earth, decreasing from poles to equator. The weight of object is the force with which Earth attracts it. The weight is equal to the product of mass and acceleration due to gravity. Weight may vary from place to place, but the mass stays constant. All objects experience a force of buoyancy when they are immersed in fluid. Objects have density less than that of liquid in which they are immersed, float on surface of liquid. If the density of object is more than density of liquid it is in which it is immersed, then it sinks in the liquid. So here ends our chapter number 10, that is gravitation. I hope you have understood it. Thank you.